Right, technical bypass. Thanks, Colin. I'm now going to focus, as Colin said, on some active learning and formative assessment ideas that can be used with the database content of the NQ courses. And I'm actually going to start with database structure. What you see in front of you here is one of the resources that was in fact developed last session by the tutor team working on database content. It's a template page that can be cut into individual pieces. If the pieces are laminated before you cut it, then with dry white markers, the pieces can all be reused. So this example here is an N5 task, a paired task is how I would use it. The working pairs or shoulder partners discuss and agree on the type of relationships that there are, and then use the template pieces to create the ERD that represents the system. And the same strategy works at higher level. And here's a sample task. What this task does is introduce the need to resolve many-to-many relationships between entities. And although that's strictly not something that hierarchy students need to know, it really does help them to understand where those strange intersection relationships come from. And it really does help them at advanced higher level, especially students who decide to do a specialist database project. At least by resolving their own many-to-many relationships, they're more likely to be able to form relationships correctly at advanced higher level. Now we have Erdish, and I'm sure you've all heard of Elvish, so now this is an opportunity to learn Erdish. And this is really important that students learn very early from N5 that all ERDs, relationships, can be read in two directions, left to right, as well as right to left. And telling students that they're about to learn some Erdish introduces a bit of fun. Doing it in a shared activity means they learn from each other in a low-stakes situation, so it's not in front of the whole class, and allows them to practice using Erdish reading the sentences. So the top one animal belongs to one classification, and a classification has many animals belonging to it. So it's learning to read in two directions. What we've got here is another structural type activity. It's for N5, and it's getting them to understand that why the primary key is the primary key. So asking them to discuss and agree whether each of the individual fields the contents would be unique. It might need a little bit of prompting at the very first attempt. So things like, would the first name attribute always contain values that are unique? Is it possible for two students to have the same date of birth? Once they get started, they're usually quite quickly able to complete the unique column and write down the reason. And that's really quite important, that the agreed reason for that decision. Yes, it's unique, or yeah, it may not, it's not unique. And once the table is completed, they should be able to identify a potential primary key. And completion of this task regularly does help them when it comes to something, scaffolding that thing that they need to be able to do in an exam, identifying the correct primary key. And gives us a chance, the teacher, to observe, which is really important in formative assessment, and to listen. And similar task at higher, where now we've got terminology of compound keys and surrogate keys, and this is another good way of developing their understanding in that low stakes situation. So let's look at some ideas to develop students' confidence and skills in analysis of database requirements and evaluation of database queries. So obviously we're looking at analysis at the moment, and this is something that is reported each year in the coursework, in the course reports, as being an area of weakness for candidates. Evaluation and analysis are both frequently identified. So once again, I've chosen to go for small paired activities, maybe small group activities, low stakes, and have a good of learning from students, an opportunity to learn from peers and iron out any misunderstandings. So there we have a task where we've got information presented with some background details and asked to identify end user and functional requirements. It can be quite daunting, and students do struggle with it initially. So to develop skills to provide and provide some scaffolding is one thing that I've found quite useful to do this. So presenting them with requirements that someone else has created. Like Colin mentioned earlier, they do like highlighting errors. So it's no bad thing to show them some requirements that are lacking in detail, some bad requirements or incorrect ones, and encourage them to discuss why they're poorly formed, maybe rate them on a scale of 1 to 5, they quickly get into the swing of doing that, and they really do like tearing apart someone else's work. The challenge here is to work together to identify the weaknesses and then work together to improve them. Similarly, evaluating their own work can be very difficult. They don't like criticising something that they've worked hard to create, and they can be rather precious about it. That very gentle testing they do, they don't really test it particularly well. They don't like proving that it doesn't work. So working in pairs to jointly evaluate whether a query is fit for purpose that someone else has written, or whether it's accurate, is a good way of tackling that. And I think because it is such a high order skill in Bloom's taxonomy, if nothing else, teachers, it really is useful to try and find some time in class to help develop the skill and help develop students' confidence in doing it. This type of scaffolding, but by providing a checklist that can be used as a basis for their discussion, does help get them to the core of what's important. It's important to remind them that they must answer the question, is the query fit for purpose? Is the query accurate? With a very definite yes or no. And they must give reasons for the response by referring to the context of the question, to the relevant clauses of the SQL query. And since they haven't invested any time in the creation of the query, they're usually quite happy to be very critical. One benefit that's been mentioned by a couple of people earlier is that what formative assessment does show is highlights misconceptions that students form as they learn new content. If we're not careful as teachers, they can join up dots between facts that actually don't exist. And as a result of those strange dots, they may come to conclusions that are in fact incorrect. And the resources that you're looking at here were also developed last year, whether or not you might not have seen them though, in last year's database materials. What we have here are 24 statements that can be cut into individual cards, which is quite a nice way of doing it, so they're not overwhelmed by them. And each one of them, they don't all have misconceptions. Some of them are true statements, some of them are misconceptions. But actively focusing on it in class means that we can kick them into touch quite early. So the 24 statements are all exemplified in what is a movie actor database, and all the details of which are on a single sheet of paper that you can see there. One way to go about it, you can pair it, they can work it in mini whiteboards, they can write it in Jotter, but a nice way of doing it is actually to sort of turn it into a sort of carousel task. I've got strange pronunciation tonight. With workstations, we say 4 statements at each station. Students work in groups to discuss a statement and discuss whether it's true or false. But importantly, of course, the critical thing here, like Kim had said with the peer instruction, is that the decision must be supported with reasons. So, for example, the statement here that says an entity can have more than one primary key is false, because an entity can only ever have one primary key. Of course, but the important thing is for higher candidates is that primary key can be a compound key formed by combining 2 or more attributes. In the movie actor database, the role entity has a compound key formed by the attributes actor ID and movie ID. So for something completely different in implementation, what we have discovered, I guess, as we've got more skilled at teaching this and more experienced at teaching database content at higher, is that one of the hardest implementation skills is definitely grouping. Many students really struggle with it and often confuse it with ordering, and that's understandable because there's a certain element of ordering which does a certain element of ordering which is associated with grouping, so I can understand where that confusion comes from. So a really worthwhile activity is to give each student their own individual set, and it can just be paper, of the 8 records from this competitor table that you see here. Peter, we've made one earlier. So they've each got their own little set of 8, and now they can forming groups that match the requirements of different queries, again, increasing the complexity of the query. And they do that by physically manipulating the records to form individual piles of records in each group. And that physical doing it helps them understand how grouping is applied within a SQL query. It kind of removes that mystery behind it, and allows the teacher to observe how students are coping with the task. Gradually increasing the complexity of the query will help the students understand what happens when data is actually grouped. And another really good way of following that through, or just testing their understanding, is to ask them to visualize the results of a query as a bar chart. So in the bar chart, each group will need a separate bar, obviously, but groups with subgroups will have separate bars for each of those subgroups. So in query 3, the one at the very bottom, for example, which groups by authority but also by level, 2 of the local authorities have 2 bars each for junior and for senior level, whereas Midlothian is the only one with 1 bar because it only in the data in the table, the basic table, which is all available on the swag bag, the students in Midlothian are only juniors. And yes, here we have, and now for something completely different. I'm sure many of you remember fuzzy felts, looking back fondly on fuzzy felts. Well, what you're looking at here is some fuzzy felt coding boards. And the great news is that you can easily create your own. Create your own class sets of fuzzy felt coding boards that can be used for some unplugged activities to develop students' coding skills. And what you really need is some stiff cards, what I've used, and these are actually real code A3 sized fuzzy felt covered coding boards, is black mountain card and a roll of black felt with some PVA glue. The coding pieces are created just of paper and then laminated with the keywords and a small piece of Velcro, just the hook side of Velcro, tiny bit on each side. And there you go. Hey presto, you've got your fuzzy felt coding set. You can use it in lots of different ways. You can work in pairs to create queries using the dry wet markers on the coding pieces. It's a low-stake way of coding, great way to boost confidence of learners. You can sometimes be reluctant to try something new, particularly younger learners could be a bit reluctant when they're at a PC. And of course, fuzzy felt coding avoids all the distractions associated with network access, forgotten logins, IT issues, and yes, colleague in West Lothian has recently borrowed 3 class sets of coding boards, of fuzzy felt coding boards. So creating fuzzy felt code is only one use of them. The individual database records that I use with the grouping could be used in fuzzy felt coding boards to build answer tables, or about a standard algorithm, stages of a standard algorithm being laminated and little bits of Velcro, and then asking kids to put them in sequence and beginning to build up that knowledge of how the algorithm looks, that type of thing. But they're also a great way of checking coding skills and a good practice at testing and evaluating skills. So one way I like to do this is to provide broken code. And you might have noticed that the queries on the previous display were broken queries. They were deliberate. I like to provide broken code. In this case, broken queries. Set the task up. I provide students with the query code, an outline of the problem the query is being used to solve. I then tell them that the query is broken and challenge them to work out what's wrong with the query, fix it, and explain how their fix improves the query's fitness for purpose. Okay, so yeah, the little checklist that I mentioned earlier can be used here as well, just to sort of help support that in the initial stages of helping them to develop the skills of identifying the broken queries. We can ask the kids to break it better. They really quite enjoy this. So as a follow-up to the serious testing and evaluating practice, I like to give students an opportunity to create their own broken queries. So go on, deliberately break queries and do it better than I did it. There are some rules that they must adhere to. Firstly, I set the query goal. Secondly, they can only introduce 1 error per broken query. Initially, I scaffold this by providing suggestions for errors. So they could introduce a syntax error, such as missing quotes or missing commas, a logical error, such as the wrong aggregate function, which is quite common, incorrect formulas for a calculation. A structural error could be added when forming the query, such as omitting a clause or putting clauses in the wrong order, or simply spelling and naming issues. Students then take it in turn to create the broken query on their fuzzy felt coding board and challenge the other student to spot the error, fix it, and comment on the query's fitness for purpose and accuracy. Colin and I have now spoken for a while about formative assessment strategies for teaching web and database content. And I think the time has come for people to let us know what you think about some of the ideas and suggestions we've made. So here's a feedback frame with some blank sticky notes. What we'd like to do is to take a few minutes, let us know what you think about some of the things we've mentioned. Would they work in your class? Which strategies would you be interested in trying? What adaptations would you make? How would it work for you? Can you see how the ideas would be useful in your teaching? It might be you can think about the idea in another area of the curriculum, or what formative assessment ideas do you use teaching database and web that you're happy to share with others. So I'm going to be quiet and give you a couple of minutes, grab one of the blank sticky notes and just jot down some thoughts. Break It Better is quite good fun. They quite like that. They do like, first of all, they like looking at things that we've deliberately broken, because they do like spotting teacher errors. I'm sure we all know that every time you're talking to them, they're waiting to spot the error. That's suddenly the class wakes up then, but Breaking It Better is really good. They do enjoy that. And the graph visualization of grouping is quite powerful. It does really let you see if they are understanding how things are grouped. So great, thanks for all your feedback and your contributions. It really is heartening to see how much computer science teachers care about their teaching and are keen to improve things for their learners. So yeah, it's really heartwarming that we all share. So now you've had a chance to think about sort of teaching the optional web and database content. I'm sure you're keen to find out more about some of the ideas that we've thought about for mandatory content. So I'm going to pass you back to Colin, who'll introduce some ideas that can be used when we're teaching mandatory systems. So back to you, Colin.